Hi everyone, welcome back to Math History. We're going to be doing a chemistry Regents review on stoichiometry. So let's read this passage. The use of elemental sulfur can result in over-acidifying agricultural soil. Utilizing alternative ammonium fertilizers such as ammonium sulfate reduces this environmental risk. Once applied to the soil matrix, dissolved ammonium ions interact with environment-facing elements. The equations below demonstrate two pathways through which these ions undergo chemical transformations. The question is asking, how many grams of nitrogen are added to the soil when exactly 100 grams of the alternative substance, which is ammonium sulfate, that acidifies the soil with reduced risk is applied? Show the work below. So the question is asking us how much of nitrogen is in ammonium sulfate here. So first we need to calculate the molar mass or the gram formula mass of ammonium sulfate. So we have one nitrogen. Well, actually, no, we have two nitrogen because this subscript here is distributed into NH4. So we have two nitrogen. So if we look at the table, the atomic mass of nitrogen is 14.01. If we multiply that by 2, we're going to get 28.02. And then hydrogen, since the 2 is being distributed, we're going to do 2 times 4. So we have 8 hydrogen. And the atomic mass for hydrogen is 1.01. So we multiply that by 8 and we get 8.08. And then we have sulfur. We only have one sulfur. So that's 32.06. And then we have 4 oxygen. And oxygen is 16. So we multiply that by 4 and we get 64. So then we add all of these up. So we're going to do 64 plus 28.02 plus 8.08 plus 32.06, and we're going to get a molar mass of 132.16 for ammonium sulfate. Now that's the entire molar mass, but the question is asking how many grams of nitrogen. So in ammonium sulfate, we have a mass of 28.02, which belongs to nitrogen. So if we were to make a proportion, our molar mass is going to go at the bottom. So the molar mass of ammonium sulfate was 132.16. And the molar mass of nitrogen was 28.02. Now these are going to be separate because, again, we're finding how much of nitrogen is in ammonium sulfate when there are 100 grams of ammonium sulfate. So then the given grams is going to go on top. So we're given that there are 100 grams of ammonium sulfate, and we want to find how much of nitrogen is in those 100 grams. So we're going to use an X, and then we're going to cross multiply. So we're going to do 100 times 28.02 and 132.16 times X, and we're going to get 2,802 is equal to 132.16x. So we're going to divide by 132.16 on both sides, and we're going to get that x is equal to 21.2. So our answer is going to be that there are 21.2 grams of nitrogen in 100 grams of ammonium sulfate. Question 2. Which provided mathematical model demonstrates that mass is conserved during the biochemical transformation shown in equation 3? So in equation 3, we're looking at this one right here. And it's talking about the conservation of mass. So that means that the mass stays balanced on both sides, or it stays the same. So if we look, the choices that we're getting is talking about moles. And the moles we can identify through their coefficient. We have 1 mole of ammonium, we have 2 moles of oxygen. Then in the product side, we have 1 mole of nitrate, we have 1 mole of water, and 2 moles of H plus or hydrogen ion. We can eliminate A because if we're talking about the conservation of mass, that means that the mass needs to stay the same. And in option A, we can see that we have less moles, meaning that it's not stay the same. So A is not going to work. Neither is C going to work because we have less moles. So now we're between B and C. Well, as I just talked about, in the reactant side, we had 1 mole of ammonium. So that works. And we had 2 moles of oxygen. That also works. We had 1 mole of nitrate. That also works. 1 mole of water. and then 2 moles of H plus. So B is true. Now, D wouldn't work because it says 2 moles of ammonium, and that's not true. So I'm going to divide this into reactants and products. So in the reactant side of equation 3, we have NH. I'm just going to rewrite this. So on the reactant side, we have nitrogen, we have hydrogen, we have oxygen. And in the product side, we also have nitrogen, we have hydrogen, and we have oxygen. So now we just count. So on the reactant side, we have 1 nitrogen, we have 4 hydrogen, and we have 4 oxygen because the 2 is multiplying to the subscript 2. So we have 4 oxygen. In the product side, we have 1 nitrogen. We have 3 oxygen here plus the other oxygen here, so that's 4 oxygen. We have 2 hydrogen here plus the other 2 hydrogen here, that's 4 hydrogen. So the amount of atoms is balanced on both the reactant and the product side. Next question. So in this question, we have this equation, and it's in the test facility. A chemical engineer introduces exactly 15 moles of CO and 33 moles of H2 into a sealed, rigid 25.0 liter reaction vessel at an elevated temperature. The reaction is monitored. Which information represents the correct molar mass of the hydrocarbon byproduct calculated using the 2025? So it's just asking to find the molar mass of this right here. So we have carbon, hydrogen, and that's it. So the mass of carbon is 12.01, but since we have 5 carbon, we're going to multiply that by 5, and we're going to get 60.05. Then for hydrogen, we know that the mass is 1.01. We multiply that by 12 because we have 12 hydrogen. That's going to be 12.12. We add those two together, and we're going to get 72.17 grams per moles. The answer is C. It's supposed to say 17 here. Based on the provided equation, select the option that correctly describes the mole-to-mole ratio of the hydrogen gas reactant to the water vapor product. So we're looking at H2 to water vapor, so H2O. So in the equation, we see that we have 11 H2 for every 5 H2O. So it's not A and it's not D. Then it says 11 moles of H2 produce 5 moles of H2O, and that is correct. Complete the mathematical representation below to calculate the total number of carbon particles present in the initially added 15 moles of CO. So this is talking about particles. So that means that we need to use 6.02 times 10 to the power of 23. So whenever we want to solve for particles, we're going to use this number right here. This is equal to 1 mole. So if 1 mole is equal to 6.02 times 10 to the power of 23, but it's asking for 15 moles, we have to multiply this by 15. And we're going to get 9.03 times 10 to the power of 24. Last question. Construct a mathematical representation and calculate the number of grams of water vapor produced if exactly 66.5 grams of H2 react completely according to the balanced equation. Your response must include a clearly written mathematical representation and final answer. So the question is asking us to find the gram of H2O. But right now, all we're given is the grams of H2. So what we need to do is we need to convert from grams of H2 to moles of H2, and then from moles of H2 to moles of H2O, and then moles of H2O to grams of H2O. Because we can't go from grams directly to grams again, we need to do a whole process. So first, let's convert grams of H2 to moles of H2. So 1 mole is equal to the given mass over the gram formula mass. So our given mass is 66.5 grams of H2. And the gram formula mass of H2, we have to do hydrogen, which is 1.01 times 2, which is going to give us 2.02 grams per mole. So we do that, and we're going to get 32.92 moles of H2. So we completed our first step. Now the second step is to get from the moles of H2 to moles of H2O. So we have this many moles of H2. So we're going to write 32.92 moles of H2 times the mole of the unknown divided by mole of known. So unknown is H2O, and according to the equation, we have 5 moles of H2O. So we're going to put 5 moles of H2O on top. Then in the bottom, moles of H2, according to the equation, is 11. So we're going to put 11 moles of H2. So these will cancel out. We're going to get around 14.9 moles of H2O. And now we just convert that back into grams of H2O. So we're going to do 14.9 moles of H2O times 1 mole underneath. And then the GFM of H2O, which is 2 hydrogen, which is 2.02, plus oxygen, which is 16. That's going to give us 18.02. So 18.02. And when we multiply these two together, and we're going to get around 269.6. However, since I did round early on, if you actually do this entire process in one go on the calculator, you're going to get around 269.7. So I'm going to write 269.7. And that is all of the steps.